Here we go, factoring. We're going to combine the two factoring methods that I've shown you already, which was the pulling out a GCF, and then also factoring by using the binomial stuff we used yesterday. So we're going to combine them together, and so I put out the steps. They're pretty straightforward. First, try and find a GCF. Second, factor out whatever is left over into a binomial if you can, okay? And so let's start with number 1, and let's see how that goes. So the first thing that we need to do for these again, like I said, is let's identify what the GCF is first, okay? Between the things that we are looking at in the expression. So the GCF in this problem, if you just look at the numbers of 3 and the 48, the biggest number that they have in common is 3, obviously, because 3 is the smallest, is small, so we're not going to get anything bigger than 3. So 3 does go into 48. Looking at the ends between the two of them, you take the n that has the smallest exponent, so n to the third. And so what we do now is we factor a 3n to the third out. So the old way we used to do this, if you need to do this, that's okay. If you've figured out how to do this more quickly, go ahead and do that. That's fine. I'm going to do it this way so that my friends who need this extra step can have it, okay? So remember, what we do with the GCF is we divided it, okay? And so what I have here right now is I have the 3's cancel out, and I'm left with an n squared. 48 divided by 3 is 16. And then the n to the third to cancel, so that goes in a parenthesis. And then remember, what I do is I write the GCF out on the outside of the parenthesis. And so now what I can do is, let's look at this parenthesis. Then look at this, n squared minus 16. We learned how to factor that yesterday, remember? So it ends up being two parentheses, two numbers or two things that multiply to get to n that are exactly the same as n and n. 16, two numbers that multiply together to get 16 is 4 and 4. So it gets n and n, 4 and 4. And then I put opposite signs here. So plus, a minus, and then I'm just going to drop down that 3n to the third over there. Okay. So the final factoring, so this is multi-step factoring here. There's more than just those few steps or one step of pulling out a GCF or doing the binomials. Okay. So let's look at number 2. Let's try the same thing here. So first thing, let's identify what the GCF is. So looking at the 5s, the 5 and the 20, the number part, their biggest number they have in common is 5. Looking at the x's, we take the x that has the smallest exponent, which is this guy, so x to the first. And if you need this step, here we go. I rewrite the original problem. This is the factoring out the GCF step. Okay. And so you simplify. The 5's in this first fraction cancel out. X to the third divided by x leaves me with x squared. 20 divided by 5 is 4. The x's cancel out. Put in a parenthesis, drop that GCF over here in front of the parenthesis. Okay. Now looking at this, x squared minus 4, it can be factored, right? X and x, 2 and 2. Opposite signs, plus, minus, 1x gets to go in the front of the first parenthesis. Oops, 2's going the wrong way. This x goes to this parenthesis. So x, oh, an x there, x there, sorry, 2 drops down there, and then 2 drops down there, and so I drop this 5x down here, sorry, and we circle this up, okay, so final answer is 5x times x plus 2, x minus 2, so here's my GCF, and then here was the binomial that we factored out. Let us look at number 3. So number 3, GCF, so it looks a little different than the rest of them, but I promise the pattern is going to end up looking the same in the end. So let's just look specifically at the u's. So the u, we take the smallest exponent, which is just u. The v, we take the smallest exponent, so we have a v to the third and a v to the first, so v, uv is our GCF. Remember, we write this out, and then we divide by our GCF. So let's simplify. So the u's cancel out. Okay, the u's cancel out, and then I have a v to the third divided by v, which leaves me with v squared. And then I have a u to the third minus u, which leaves me with u squared, and the v's cancel out, so I close this parenthesis. I'm going to drop my GCF in the front. Okay, and so now we break this parenthesis down. So v squared can be split into vv, u squared into uu. So I have one of the v's goes in the first parenthesis, the other v goes in the second. Remember, we have to preserve the order, so since the v is first in the original problem, it has to go first in the answer. A u goes in the first parenthesis, goes in the second. Make sure each parenthesis has opposite signs. Rewrite our GCF. And there's our final answer for this guy. Okay, so pretty easy, I hope. Let's see, we're going to get into some of the more, I have a to the fourth, so let's see how this one's going to work here. But following the steps, here we go. GCF between the two of these. So we got to figure out what the GCF first. Let's do between 36 and 16. So what's the number that they both have in common, the biggest number they have in common? It's 4, okay? Looking at the a's, we take the smallest exponent a, which is a squared. Let's rewrite the original problem. Excuse me. Divide by the GCF. Okay, so what do I have? 36 divided by 4 is 9, and the a squares cancel out. 16 divided by 4 is 4. A to the fourth divided by a squared is a squared. Close it. GCF I rewrite on the outside. Okay. Let's do that, sorry. Here we go. And now what we can do is we can do our binomials here. So we go like this. Opposite signs. Remember to preserve the order, so 9 is 3 and 3, two numbers exactly the same that multiply to 9 is 3 and 3, so the 3's have to go in the front. 4 can go 2 and 2, a and a, so I get a 2a that can go there, a 2a that can go there, and then I drop the GCF down. So final answer for this guy, 4a squared, 3 plus 2a, 3 minus 2a. And we have arrived at the last problem of the day. Here we go, GCF. GCF for the 2 and the 162, wow, that's a big number, 2 and 162, the GCF is 2. Between the a's, we take the smallest a, which is just a to the first. Rewrite the problem. Divide by the GCF. Okay. The 2's cancel out. A to the fifth divided by a is going to leave me with a to the fourth up. This is an a to the fourth problem, just like yesterday, so we might have to do some extra factoring. We'll see, okay? 162 divided by 2 is actually going to give me 81. A's cancel out, so I close. I'll drop my 2a here. Okay. A to the fourth, so two numbers exactly the same, or two things exactly the same, that's going to give me a to the fourth. Remember, last lesson we established that a to the fourths, or things to the fourth, ends up being squared and squared, right? 81 we can do like regular. 9 and 9 are two things exactly the same. So here we go. Here's my two parentheses. One gets a plus, one gets a minus. It becomes a squared drops down here, a squared drops down here. I get a 9, and I get a 9. Drop that 2a down. And so, because it's a to the fourth, double check before you box that, okay? So the 2a, definitely nothing I can do there. A squared plus 9. No. Why again? Because this is a plus, so I can't do anything with this, okay? I have a minus in between here, so this might be able to. Are there two things exactly the same that can give me a squared? Two things exactly the same that could give me 9. So, yikes, I gotta keep going here. Okay, so the 2a can stay. The a squared plus 9 can stay. Oops, it looks like a squared plus a. Sorry, a squared plus 9. There we go. And then we go two parentheses one more time. So I get to put opposite signs in here. Plus, minus, I get an A that gets to drop down there, an A that gets to drop down there, a 3, and then a 3. Looking at this, there's nothing more I can do here. Okay? So it ends up being 2A, A squared plus 9, A plus 3, A minus 3. It's a super long answer for a problem like a number 5 that started off so short. So be careful. Once you get into A to the 4th territory or anything even necessarily bigger than A squared, there may be extra factoring, so be careful. So that's it. Don't forget to take the quiz and write down any questions you have.